Hello and welcome back. This is a new mini series on quantum mechanics, quantum physics, and all things quantum in science. We may not cover much of quantum computing, that is not the idea, but it will eventually lead into quantum computing. Quantum mechanics and physics is much larger. It gives us a much better understanding of the world before we even start talking about quantum computing. So, let's look at why this series exists and why quantum mechanics really matters. At some point in life, once curiosity returns, we usually get a question like, what is this world actually made of? We have all these objects, solids, liquids, so many things around us. What is it made of? Atoms, electrons? Yeah, I do understand, but what exactly is it? So, this series exists for that moment. It exists because many of us were introduced to physics in a way that kind of stripped off the meaning. We were given a lot of answers without the questions that were asked to create these answers. We don't know the background. So somewhere along the way, our curiosity was replaced by performance, memorization, those kind of things. But physics, and I believe, is one of humanity's deepest attempts to understand reality. It began to feel distant and inaccessible because we used a certain method to understand physics. We did not look into the background of how it evolved. So this series is an attempt to undo all of that. Not by oversimplifying physics, not by turning it into some kind of entertainment or spectacle, but by returning to the questions that made physics necessary in the first place. Why does matter exist at all? Why does light behave the way it does? Or why does universe feel solid and predictable? So physics exists because those questions refused to go away. For a long time, the answers seemed complete. The universe appeared orderly, mechanical, predictable. Objects moved when forces acted on them. Time kind of flowed forward at the same pace for everyone. Light behaved like waves. So many things. And for everyday life, that picture works beautifully. It allows us to build bridges, we can predict planets, machines can run. But when physicists began to look deeper, far deeper than human senses allow, reality began to push back. So atoms did not behave like tiny solid objects, the ones that we are used to. Light refused to choose whether it is a wave or a particle. And not only that, and the act of observation itself seemed to matter. Energy also started moving in discrete jumps instead of smooth flows. So this is what happens at a small, micro or minute level. So the universe is not broken. It's just that our assumptions are. So quantum mechanics was not invented because physicists wanted some kind of mystery in science. No, it emerged because experiments demanded more honest answers. What does that mean? So classical physics stops working at a very minute level. That's where we need new answers. So we came up with new equations, the equations worked, but we came up with new predictions which were accurate, but the implications were really unsettling. Certainty gave way to probability. So the certainty of having an answer now gave way to a probability of having an answer. Particles began behaving less like things and more like possibilities. So if you look at an electron, you can never really pinpoint where an electron is. It is always a probability. It's not a new theory, it's just a shift in our worldview. So quantum mechanics suggested that the universe is not a clockwork machine ticking predictably beneath the surface. Instead, it behaves like a system of tendencies, rules governing what can happen, not what must happen. Outcomes exist as probabilities until all these forces and interactions they give us a resolution. So it's like, that sentence is pretty much loaded. Outcome or the result that you're expecting, it exists as a probability, something that could happen. Okay, until interactions and forces they kind of all come together to force a resolution. If you tweak all the right buttons, now the probability will become more certain. So that is how quantum mechanics works. So let's look at it in detail in this mini series. This feels strange not because it is wrong, but because our intuition evolved in a world where quantum effects were kind of averaged out. We used to say, okay, this person exists at this location, he's here. Really? Yeah, he is. I'm not conjuring up some magic, but yeah, that's how quantum mechanics works. We'll look into all those details. At human scales, uncertainty fades into stability. I'm looking at you, there is a camera, I know that somebody is watching on the other side. There is no uncertainty, it is certain. probabilities kind of collapse into solid tables, flowing water, predictable motion, all of these things. But beneath that surface, the quantum world is always there. If you go down to the smallest level, atoms do not collapse because quantum rules are preventing them from doing so. Not so. So, a lot of things, we'll go through all of those in detail in this series, episode by episode. So, quantum mechanics is not a corner of physics, it is more or less the foundation of physics. And yet, despite shaping nearly everything around us, it is often introduced in ways that kind of alienate us from the understanding, with a lot of dense mathematics, without much intuition, lot of dramatic metaphors without understanding how it is. So this series takes a different path. We will move slowly. We will build intuition before equations, and we will allow for confusion without treating it as a failure. That's how we are going to move. So as we move forward, we will follow the same path physicists themselves were forced to take, starting with the moments where classical physics stopped working and tracing the reasoning that led to quantum ideas. Along the way, we'll look at concepts like wave particle duality, superposition, uncertainty, entanglement, all of those things much later in this journey. We will also look at how technology enters this conversation. We will look at how quantum computing will appear not as futuristic, some magic, but as a natural extension of how reality already behaves. So we begin with a shift in that perspective, with letting go of that certainty. Quantum mechanics is not a theory that needs to be just learned, it is a way of seeing things. And once you begin to see the universe this way, you cannot unsee it. If you are here because something in you wants to understand a little more, not to use it, not to sell it, but simply to see clearly, this journey is for you, and this is where we begin. So follow me in the next set of episodes. I'll see you in the first episode in a minute's time. Thank you for watching.